and then we'll start in on our practice test. But here we go. Side 2 of the practice quiz says, got a triangle that looks like this. And my job is to find A. That's it. One job only, and that is to find A. So, remember that when we are finding sides or angles, when we're finding sides or angles, we have to use either the law of sines or the law of cosines. So which would it be? Take a look at the given, how it's set up. Which do you think it should be? Is this a law of sines problem or a law of cosines problem?
Law of cosines.
Absolutely. Because if it were going to be sines, if it were going to be a law of sines, we would have to have a pair, right? And we don't have a pair. We don't have A and A, K and K, F and F. We don't have it. So this is going to be a cosine law. Now, when we do the law of cosines, remember on this end out here goes cosine of the angle. So the angle is 28. So that's going to be cosine 28. On this end then is the angle's side, which would be A in this case, squared. So we got A squared on this side, and we have cosine A on that side. Who remembers what's in the middle?
It would be 17 squared plus 13 squared equal or minus 2 times 17 times 13.
That's right, and that's times that. It's 2 times 17 times 13 times cosine 28. This is all a big multiplication here. That's exactly right. So the other two sides are 17 and 13. So we square one plus square the other one minus 2 times them times each other times the cosine of 28. Perfect. And any time that your variable is just sitting over here all by itself, you just type it in. So 17 squared plus 13 squared minus 2 times 17 times 13 times cosine 28. Now your calculator should already be set in degrees. If it's not, make sure it is. I'm not sure. What answer did you come up with when you typed all that in?
67.737.
Yep. Now be careful though, because what's 67?
You have to square it.
Square root it. Yep. Don't forget you need to square root it. So when you square root that number, we get 8.23. And for our quiz tomorrow, or next time, that's all we need. It said find side A. We just found side A. All right. Then we've got number 2A on side 2 of our practice quiz. Gives me this information, and it says find the area.
Don't you add up the 10, 12, and 16 and then divide it by 2?
You do.
Yeah, find the semi.
That's, yeah. So, was that you talking, Caroline?
Yeah.
Okay. Yeah, so Caroline said, we're going to add up all the sides and divide by 2. And then Mary Kate said we need the semi-perimeter, and they're both the same thing. They both said the same thing. So our semi-perimeter will be, let's see, if I add all these up,
19.
well, I get 38, but half of that's 19, right? So remember, you need half the perimeter. So you add them up and divide by 2. Take half of it. So when we find the area, then, we're going to use Hero's formula, which is the big radical. And the first number under the radical is at 19. Then there's 3 more numbers under there. And who remembers where they come from?
You do 19 minus each side.
19 minus each side. In any order doesn't make a difference. So 19 minus 10, 19 minus 16, and 19 minus 12. Perfect. Now, type it all in. My variable's over here. I wonder what the area is. What does that equal? So 19 times 9 times 3 times 7. And then square root that, of course. And your area is 59.92. Okay. Another area problem. This one, the information is different, isn't it? I don't have all 3 sides, but can I find the area of that triangle?
Yeah.
Yeah, it's actually easier, isn't it? What's the setup for this kind of situation?
I don't remember that part.
Does someone remember?
Area equals 1/2, and then you multiply it by the 2 sides, so 10, 17, and then you multiply it by cosine 80, or sine 83.
Yep, sine 83. And so if it helps at all, the formula is 1/2 side, side, sine. So if that alliteration helps you remember it's sine, then use it. 1/2 side, side, sine. That's exactly right. Who remembers, though, the rule about the angle? You can't use just any angle. What angle do you have to use?
The one in the middle.
The one in between the 2 sides. That's exactly right. So 1/2 times 10 times 17 times sine 83. Don't square root this. Whatever you get, that's the answer, folks. It's 84.37. Okay?
And our quiz is tomorrow or Wednesday?
Our next class, whenever I see you again, does anyone know when that is? I have no idea.
It's going to be on Wednesday.
Okay. Then that's when it is. I'm happy to say that's when it is. Okay. All right, so now let's get out our practice test because we finished our notes last time. This test should be an easy one. There's only 3 sections. And we had a quiz, or we will have had a quiz over every section. So hopefully we'll start off quarter 4 with a really, really good test.
Where are we?
We're on our practice tests. Just starting practice test number 1. And it says simplify the following. So we're going to simplify this. And this, there's 2 of them. All right? So you tell me, how might we simplify the first one? Can we do anything with that?
You can take one sine out.
Okay, we call that factoring. We absolutely can factor. That's a great suggestion. So let's take out a sine. And if I pull out one sine from both terms, what will I have left? What's left here first? If I take out a sine.
Sine squared.
Perfect.
Yeah.
Sine squared. If you take out one sine from a sine cubed, you're going to have sine squared. Right. Plus, what am I going to have left here?
Cosine squared, so it's going to equal sine x1.
Exactly. I've still got my sine, but we have memorized that sine squared plus cosine squared is just 1, and that's a multiplication, so we end up with just sine. Sine times 1, which is just sine. Very, very good. Okay. Now, what about this one? Anybody have a suggestion for this one?
Well, cotangent is cosine over sine.
Okay, so what she's
And then-
suggesting is we change these into the fraction form. All right, so what's cosecant?
Cosecant is 1 over sine.
Perfect. So now remember they're over each other. They're not times each other. They're divided by. So I have this big division now where I have cosine over sine divided by 1 over sine. Cosine over sine divided by 1 over sine. Well, what do I do when I have a big division like that?
Reciprocal, so you multiply by sine over.
Exactly. So this would be cosine over sine times sine over 1. When I divide by a fraction, I multiply by its reciprocal. What happens?
The sines cancel.
Yes, they do. And leave me with just cosine over 1 or just plain old cosine. Now, let's not forget, what do our tests always look like? What do they always look like, kids?
Practice test.
Exactly. So we're going to have 2 problems that look like these 2 on the practice test. I know you're a little uncomfortable with those sometimes, but there's only going to be 2. And then you're going to have a bunch of triangles. Now the directions here say solve. I have put answer blanks over to the side so you know exactly what you need to find. You need to find angle A, and side C. I think one of those you can find right off the bat. What do we know right off the bat?
68.
Yeah,
A is 60.
yeah, we know angle A is 68. Because the angles of a triangle always add up to 180, right? So that part's done. Now, to solve a triangle, to find angles and sides, we use the law of sines or cosines. Which one shall we use for this particular problem?
Sine.
It's going to be a law of sines problem. And we know it's a law of sines problem, kids, because of this right here. Look here. See that right there? That means law of sines. And you start with that. So sine 50 over 16. And then you're going to set it equal to whatever other pair you want. Yeah, so what? What were you saying?
Sine 60. Jada.
Oh, Jada, yeah, what were you saying?
Sine 68 over A.
Yep. That's absolutely fine. It could also be sine 62 over c, right, gang? It doesn't matter. It doesn't matter which pair you go for. Just pick one and go for it. All right, so what do we do after we get our proportions set up?
Cross multiply.
Yep. So a sine 50 equals 16 sine 68.
Divide.
And divide, remember what your variable is, so you want to divide by the other thing, so we're going to divide by sine 50. So 16 sine 68 over sine 50. I just type that in. See how it says A equals? That's your clue, you just type it in. 16 sine 68, close parentheses, divided by sine 50. I got 19.37. What was that A? Anybody have a question about that? Okay. Now what?
Now you have to set up another one.
Yep, I'm going to set up exactly the same situation. I'm going to go back and use sine 50 over 16. But this time, I'm going to set it equal to sine 62 over c.
And then c sine 50 equals 16 sine 62. And then divide by sine 50.
Yep. So in other words, aren't we doing exactly the same thing over again? We do exactly the same thing 2 times in a row. So 16 sine 62, close parentheses, divided by sine 50. I got 18.44. All right. Everybody good with that problem? Well, there's another one that has exactly the same directions on the back. Now, I want you to be really careful when you look at this problem. I want you to make sure you read the directions. Because earlier today, when I put this problem up on the board, somebody said, find the semi-perimeter. No. When do I need to find the semi-perimeter?
If you're finding the area.
Exactly. And I am not finding the area. I am finding angle D, E, and F. I'm finding all of the angles. Okay? So Ari, I can't see you. Ella, Isaac, Jada, William, you're black on the screen. Thank you. Chase, I can't see you either. Come on, guys, you know the drill. Okay, so if my job is to find angles and sides, then I don't use semi-perimeter and all that. I have to use my law of sines or cosines. So which is it going to be, the law of sines or the law of cosines?
Cosine.
Yes.
Cosines.
And we know it's cosines, guys, because we do not have a pair. If you don't have any angles, there's no way you're going to have a pair, right? So let's find the biggest angle first. Let's find the big one. Which of those angles, excuse me, D, E, or F, would be the big one? What did you say?
E.
Yep, E is big. How do I know E is the big one?
That's the part.
Its partner.
Its partner is the biggest side. So let's find angle E. Now, if I know I'm going to find angle E, then I'm going to put 16 squared over here and cosine E over here. Remember in the law of cosines, whatever angle you're using, which I picked E, or you told me E, but we were gonna do the biggest one, so it's E. That means its side is over here by itself. Does that make sense to everybody? Okay, so what goes in the middle?
Do you have to do with the biggest one?
You don't have to, but there is a little bit of an issue that can happen. So I would suggest if you're starting with the law of cosines, you start with the biggest one.
Okay, because I tried to do it with a different one and it was an error.
That shouldn't happen. You shouldn't get an error, yeah. Well, anyhow, let's do this and see what happens. So, so we get, what goes in the middle here? We've got my 16 squared over here, that's side E. What's all of this gonna be?
It'd be 12 squared plus 10 squared minus 2 times 12 times 10.
And then times cosine E. Now, Annie has answered that question both times. I need to make sure you all know that's what goes in the middle. Is everybody clear that if I put the 16 squared over here, then in the middle is going to be the 12 squared plus 10 squared minus 2, 10, 12 cosine E. This
Miss
is,
Ward, I have a question.
Uh-huh.
Why did you put 16 instead of E squared?
because I know side E. I know side E. It's 16.
Mm-hmm.
My variable is angle E. I don't want to have two variables in my problem. I don't need to have two variables in my problem. This is
okay.
E squared, but I know what E is. It's 16.
Okay.
Okay? Now, this one's a little harder to type in because notice the variable isn't all by itself. The variable is attached to a whole bunch of stuff. So let's go through, and this may have been why you got an error. You may have typed it in wrong. So let's go through and do all the squaring and multiplication. So 256 equals 144 plus 100. You can use your calculator to help you with all of this calculating. 2 times 12 times 10 is 240. And that's times cosine E. So what I have done is simply start doing some of the arithmetic. All right, everybody good with that? Okay, so now I'm going to go ahead and add these two together. So 256 equals 244 minus 240 cosine E. 240 cosine E. Now, if you subtract these two numbers, it's going to be bad news. Do not subtract those two numbers. You cannot subtract because this one's hooked to a cosine. So what are we going to do instead? I cannot subtract 244 minus 240. Don't do that. What should I do?
Put it on the other side.
Put the 244 on the other side. So I'm going to subtract the 244. So 12 equals negative 240 cosine E. Now what? This is my variable. Now what am I going to do?
Divided by second cosine.
Well, I'm going to
negative
divide by
240.
negative 240 first. So I have 12 over negative 240 equals cosine E. Now I will second cosine that fraction. So second cosine 12 divided by negative 240. Don't forget to put the negative in. And I got 92.87.
Miss Ford, in the calculator, did you just put the fraction after the second cosine?
Yep. E is second cosine 12 over negative 240. Anytime your variable is cosine, you're going to second cosine to get your answer. Anytime your variable is cosine E. Now, that was a lot of work A lot of time, but we are not finished with this problem, right? All we have done is figured out angle E. So what are we going to do now?
Law of sine.
Yeah, now everybody see this, folks? Everybody see that? Now you can use the law of sines. Now, if you don't want to do the law of sines, could you do what we just did for angle D, for example? Could you repeat the process for angle D? You sure could. But you can also, at this point, use the law of sines. So what will that look like if I decide I'm going to use the law of sines?
Be sine 92.87 over 16 equals sine D over 12.
Yep. That'll work. And then, what do we do?
You cross multiply, so
Yeah.
16 sine D equals 12 sine 92.87, and then divide by 16.
Yep. Yep. And then what? What do I type into my calculator? Second sine. 12 sine 92.87, close parentheses, divided by 16. I got 48.51. Anybody get that? Nod or something? Clap? Yep, there we go. Okay.
Mrs. Score,
Yep.
I did F for that one,
Okay.
and I got 51.37, but then I added them together and subtracted by 180, but I got a different number for D.
You did, because your F is wrong. Your F is wrong.
Okay.
I mean, F can't be bigger than D. So if my D is right, which somebody matched me, so I think it is, but yeah.
Yeah, for my F, I got 38.62.
Yeah. Did you find F or did you get it by subtracting?
I found F first.
Okay. Yeah, so recheck your calculation, Caroline. Make sure you have it set up. Sine 92 over 16 equals sine F over 10. And you should get, oops,
I got 38.62.
yep, that's what you should end up with. Now, if you found F first, like Annie did, we may be off like 100th or something. Sometimes that happens, and that's why you have lots of room to show your work so that I can see what order you did things. But we should never be off more than that. All right, did you find your mistake, Caroline?
Yeah, I accidentally put like the 10 times sign and just doing, instead of doing 10 sign.
Okay. Okay, as long as you figured out what you're doing, all right. And that problem is now finished. Anybody have a question about that? Okay, now we're going on to the next section, which is the how many triangles are possible section. So when we got to figure out how many triangles are possible, does anybody remember how we do this? This was on your last quiz.
you have to do sine 61 over 14 equals sine c over 12.
Yeah, so she's exactly right, guys. Do you remember that you set up your law signs? And you just go ahead and do what you always do. You cross multiply. And then your variable is sine c, so you're going to divide by 14. And then you're going to second sine 12 sine 61 divided by 14. Now, when you do that, what's going to happen? You're either going to get an answer or you're going to get an error, right? And if you get an error, what does that mean?
It's 0.
Yep, no triangles possible. Remember, the answer to these how many triangles are possible questions are 0, 1, or 2. All right, so let's see if we get an answer. Second sine 12 sine 61, close parentheses, divided by 14. Whoa, I got an answer, did you? So that means there's at least one. Now, to see if there's another one, I'm going to go ahead and draw my picture again. But I'm going to check to see if the other angle C might work. Now, if there is another angle C, it is always 180 minus the first one. So I'm just going to take 180 minus what's on my calculator, and this would be 131.44. That second angle is always 180 minus the first one. Now, is that second triangle possible? Does that make sense?
No.
You're right. Why not?
It's greater than 180.
Yeah, you can't have a 61 and a 131. You're already over 180, so you wouldn't be able to have that angle. So that triangle doesn't work, which means how many triangles are possible? 1. Next one. The setup for all of these is exactly the same. So we're going to start out with sine 52 over 6 equals sine c over 10. Then we will cross multiply. So 6 sine c equals 10 sine 52. This is your variable, sine c. So we'll divide both sides by 6. And c will be second sine 10 sine 52 over 6. All right, go ahead and type that in.
For all of these, we always do second sine.
Well, because you're always setting up the law signs. So your variable is always going to be sine c, or sine something, yeah. What did you get?
Error.
Uh-oh, how many triangles are possible?
0.
0. Your calculator doesn't lie unless you're typing it in wrong. Make sure you're typing it in right. All right, one more, like this. So 68, 20, and 19. Hopefully you're all busily writing sine 68 over 19 equals sine C over 20. So for this one, here's what I'm typing in. When you get ready to type in, look up here and make sure this is what you're typing in. Does that jive with what you've got? I got 77.42. Did anybody else get that? Nods? Okay. Now, remember, some of you, I think, always put down 2. Sometimes if you get 1, and that happened in our first example, you might get 2, but you have to check and see. So the second angle, if there is a second angle, will be 180 minus the first one. So it's 102.58. Now, is there a possibility of having a triangle with a 68 and a 102? Does that work? Yes, I'm seeing thumbs up all over. You're right, that works. So there are 2 triangles possible. That problem has 2 triangles possible. Does anyone have a question about that? Okay. Now we're doing area. The next page says find area. So here we go. First triangle. Oh man. This section has 2 easy problems and a hard one, and this is the hard one. What makes this one hard? What's wrong with it?
It's not hard, we just gotta find the angle.
Or the side, that's right. It's not hard at all, it's just I don't have what I need. So Gabe says, well, Mrs. Ford, you know angle R. Angle R would be 52. Did I subtract right, I think? Yeah. Now, if my job is to find area, what do I need to have? I either need all 3 sides so that I can do the big radical one, right, with the semi-perimeter, or I need 2 sides and the included angle. So if I could find side Q, would I have what I need to find the area?
So wait, could you do signs first with R?
Can you do the law of signs?
Yeah, with R.
Okay, so can I what now? Tell me again.
The law of signs with R.
Yes,
Fine.
yes, that's what we're going to do. We're going to find side Q by doing the law of sines with sine 52 over 6 equals sine 47 over Q. Yes, I am doing the law of sines. Now, Q, though, is not the answer to the question. Remember, we're finding area. Q is going to help me find the area, but it itself won't be the answer. All right, here we go. Q sine 52 equals 6 sine 47. So Q is my variable, so I'll divide by sine 52, and Q equals 6 sine 47 over sine 52. I just type that in. I don't second sign that, right? I just type it in. 6 sine 47 close parentheses divided by sine 52. I got 5.57. Now can I find area? Yep, because now I can do 1/2 side times side times sine. Now be careful. If you're using these two sides, then the angle you have to use is 81. It is the angle between these two sides. So sine 81. $16.50 is the answer to the question. Of the 3 area problems, that is by far the most challenging. Does anyone have a question about it? All right, let's look at the other 2. They're super simple. Your job is to find the area of this triangle. And isn't this one ready to go right now? What's the area of this triangle? 1/2 times
11 times 18 times sine 61.
Perfect. Kids, when you have 2 sides and the angle in between, boom, you have your area. You just type it in. There's no work to show, just this equation. So 0.5 times 11 times 18 times sine 61. I got to make sure you write down your equation so I know where your answer came from. But that's it, 86.59. And then how about the next one? It is just as easy, although it takes a tiny bit more work. What do we do here to find the area?
What did we,
Perimeter.
Yeah, so what were you saying, Ari?
is that? It's okay.
Yeah, the semi-perimeter. And what is, Ari, what is the semi-perimeter? I mean the number. What is the number that represents the semi-perimeter?
Is it 14?
It is 14. Does everybody agree with her that it's 14? So that's the first number in the radical. Remember, there's 4 of them under here. The first one is the semi-perimeter, which is 14. Now, take 14 minus each of these. Do not put these numbers under the radical. It's 14 minus them. So it'll be 3, 6, and 5. 14 minus each side. You can use your calculator to help you with that subtraction if you need to. Don't forget, when you type them all together, you got to take the square root. So I got 35.50 as my area. All right. All we have have left, kids, is a few word problems, and then this practice test is done. Oh my goodness, it's easy. Easy, easy. Here we go. Find the area of a regular octagon inscribed in a circle with a radius of 12. So who remembers, we walked through a couple of these the other day. What's our strategy? Start with a circle. Now, what does octagon mean?
And then you put 8 dots around it.
8 dots. And we're going to space them out as best we can. Yep. Nobody's grading our octagon, no. So just do the best you can. Connect your dots with straight lines. And there's your octagon inscribed in a circle with a radius of 12. So go from the center to one of your dots, and that's 12. That's a radius. And actually, there are a whole bunch of radii. And they're all 12, right? Don't waste time labeling them all. You don't need to. Because basically, we're interested in one of the triangles. You're finding area. Area means it would be awesome if I knew this purple angle, because then the area of the triangle would be 1/2 12 12 sine that angle, because it's between the two sides. You can find that angle real easy. Who remembers? How do we find that angle, that central angle? Ay, ay, ay. Exactly. There's 8 of them around here, guys, and they're all equal and they make a circle. So 360 divided by 8. Is that 45?
Yeah.
So you can find the area of the triangle by doing 1/2 12 12 sine 45. That's that triangle right there. So 1/2 times 12 times 12 times sine 45. I got 50 point something. But that's not the answer to the question. That's the area of this triangle. So if we want the area of the whole shape, we'll have to do what with this answer?
Multiply by 8.
Yep, multiply it by 8, because there's 8 of those triangles this time. So the octagon area is 407.29, and this is a word problem. Make sure you put square inches. Does that look familiar to everybody from last week? All right, now we have a rhombus. A rhombus is a parallelogram with all sides congruent, or a quadrilateral with all sides congruent. And it says the smaller angle is 34 degrees. So that's 34 degrees right there. And our job is to find the shorter diagonal. Now, there's 2 diagonals. There's the one right here. Look at where my fingers are. There's that one. And then there's this one. So this is diagonal 1. This is diagonal 2. Which one is shorter? That one's shorter.
2.
1. This was shorter. This one right here is shorter. Kids, that's a shorter distance than this is. All right, I have to find the length of it. Now, I know what you are thinking. You're thinking, oh good, 1/2 side of included angle. But no, that isn't what we're doing. We are finding that length. And when we find a length, we either have to do law of sines or law of cosines. So take a look at it and tell me which you think we should do.
Law of cosine?
Yes, because we do not have a pair. So out here is going to be x squared and out equals, and out here is going to be cosine 34. And then what will be in the middle? Somebody besides Annie, because Annie's got this. What's going to be in the middle here?
16 squared plus 16 squared minus 2, 16.
Yep, times cosine 34. Yep, that's exactly right. This is not a hard one to type in. Your variable's over here by itself. So we're just going to type in 16 squared plus 16 squared minus 2 times 16 times 16 times cosine 34. Now, what do we have to remember to do though? That is so easy, but what? Square root it. So 9.36 is the answer to the question. 9.36. All right, so the next one talks about my same rhombus. So here's my rhombus, 16, 16, 16, 16, 34 degrees. There's my rhombus. Now I want to know the area of the rhombus. Okay? Now, this is a different problem now. Same picture, but a whole different problem. Should I draw in that same diagonal? Would that help me find my area?
No.
Yes, it does help me. I can do it other ways, but it does help me because isn't this a triangle right here? And isn't the area of that triangle going to be 1/2 16, 16 sine 34? Isn't that the area of this triangle right here?
Yes.
So then how will I find the area of the whole rhombus? What will I need to do to get the whole rhombus?
Multiply by 2 at the end.
Bingo, multiply by 2 at the end because there's 2 of these triangles in the picture. So the answer turns out to be 143.15. I just take this answer and hit times 2. When we drew in that diagonal, we split our rhombus into 2 congruent triangles. So we found the area of one of them, 1/2 side sine, and just doubled it. Does that make sense to everybody? All right, last one, and then I'll shut up. Here we go. I got another figure inside a circle. How many dots do I need for a hexagon? Hex. 6. So I got my 6 dots and I got them all connected. Now what do I need to do?
Put the radius in.
Yep.
Yes.
And my radius is 14.
Couldn't you do
Okay, you cut out.
360 divided by 6?
Yes, I need my angle. I need my angle. And my angle will be 360 divided by 6 this time. Is that clear with everybody? All right, what are you doing now? Are you figuring out?
14.
Is it? Yeah.
560.
Okay, so you're going to take 1/2, 14 sine 60, keeping in mind that that's the area of the triangle, right?
So would it be that answer times 6?
Yep, then we'll take it times 6. All right, and you should have come up with an answer then. And your final answer is 509.22. And we need a unit on that, so it was 14 what? Inches? So square inches. What do you think about that, guys? Everybody okay with it?
Is there office hours tomorrow?
Yes, tomorrow's day 5, yep. Yep. All right, everybody okay? Well, we just finished the practice test. Good work. I will see you
Thank you.
one of these days. Bye.
Thank you, Miss Ford.
Have a good day.
Thank you.
Bye,
Thank you,
you're
Miss Ford.
welcome. Bye-bye. You're welcome. Okay.